Today, I'll be talking about Kubernetes power for VMs using Kubevirt. Yes, you are hearing right. Like we can, leverage Kubernetes for virtual machines, and that can be done using a project, a very awesome and cool project, Kubevirt, and it's pretty interesting. My name is Sayam Pathak, and I work for Sivo, which provides the first ever managed Kubernetes service based on K3s. So you can reach me out on Twitter or anywhere on the Slack, Kubernetes Slack, CNCF Slacks. I'm all there. And this is my YouTube channel where you can find all the amazing cloud native content. And I also have written a book on Kubernetes CKS certification. So you can check that out. So today's topic is Kubevirt, and this is what we are going to cover. Introduction to Kubevirt, why Kubevirt, why it's important, its architecture, and kind of the VM flow. I want to cover the virtual machine flow, which is there, so that you understand how a virtual machine can run inside a Kubernetes cluster. And then we'll do a live migration demo. So what is Kubevirt? Kubevirt is a Kubernetes extension that allows running traditional VM workloads natively side by side with container workloads. Now that sounds fancy and interesting, right? You can run your virtual machine workloads side by side to container workloads inside the same powerhouse of Kubernetes. So I think it has opened a lot of opportunities for the organizations to adopt cloud native early, or who are transitioning into the cloud native ecosystem. Now this is very important because when now we are moving into everybody is moving into the cloud native ecosystem. People obviously have been running their workloads traditionally inside the virtual machines, and some workloads still either they are too complex to containerize, or they are very good running inside the virtual machines, or they are specific virtual machine use cases. But still, what happens is, with the power of Kubernetes and with the power of cloud native, the organizations want to leverage the power of Kubernetes and a lot more over there. Let's see why Kubevirt. So traditionally on the left hand side, you can see you have hardware, and not traditionally, even now you have hardware, you have operating system, you'll be having a VM platform, and your VM workload will be there. So that is there. And now the organizations are moving to the cloud native ecosystem. So you have a hardware, you have an operating system layer, and now you have a Kubernetes layer on top of that. So on the operating system, you have Kubernetes, and then there you are running your containerized workloads. So this is basically before Kubevirt. Like you don't have Kubevirt, this is how you are balancing, and this is how you are running your workloads. Now you are having your own set of metrics, own set of logging, own set of monitoring, scheduling, network, which is there for your virtual machines, and you are having same set of common features which are there for your Kubernetes. And some of these things you are having a custom code or customizations, a lot of customizations done around the VM side, whereas in Kubernetes, out of the box, you get amazing scheduling, network capabilities, the interfaces, and a lot more, the monitoring out of the box and all that stuff. So you want to leverage that. We don't want duplicacy, right? We don't want the duplication of all the layers that you can see in the middle. So with that, people came up with an approach with a very cool project called Kubevirt, which lets you run both of them side by side. So this is how it look like. You have hardware OS Kubernetes, and you have a VM and container workload side by side. Obviously, on top of Kubernetes, we'll be installing Kubevirt and the CRDs. So it's basically the controllers which are running. So that's the power of Kubernetes, right? You can extend Kubernetes. So that is why we always talk the main feature of Kubernetes is extending Kubernetes. Now we are extending Kubernetes in such a way that we are able to run VM workloads side by side of container workloads. We can use the same logging, we can use the same metrics, we can use the same monitoring solution, we can use the scheduling power of Kubernetes, and we can use the network. So internally, VM workload will be running as a pod inside your cluster, as a regular pod. So when you run kubectl run nginx -image in nginx, so it creates a pod. Similarly, when you'll be creating a custom resource, I'll tell you more about that in the next slide. So it will be creating a pod inside your cluster, and it will be scheduled in the same way. And if you want to leverage other capabilities of Kubernetes like source request, so everything you can leverage. The power of Kubernetes you can leverage, and Kubernetes powers are a lot more. So you will be able to leverage that for VM workloads as well. So that's the real essence of Kubevirt. Now benefits, I told you, like it increases the Kubernetes adoption for the VM based workloads. Now it's no more like, I have a VM workload which is too complex to containerize, and I want to keep it that way, but I want to leverage Kubernetes. I want to move to Kubernetes. You can very kind of easily and very in a smooth manner and in an efficient manner. Same infra and tooling. Yes, I can use the same infrastructure and tooling now. I don't have to maintain two separate infrastructures, two separate amount of code, two separate logging services, two separate monitoring services. I don't have to do that. Declarative API. It might be underrated feature, but I think it's very important. I can use the same tooling. I can use the same kubectl or kubectl or kubectl, whatever you want to call. So I can use the same kubectl command to interact with my containerized workload. I can use the same kubectl command to interact with my VM workload. So I think using the same tooling becomes very important over here. Now, declarative API means whenever I write a pod deployment or a service, I write a manifest, so a YAML file. So that YAML file is having, a certain set of fields. It has a spec section where I define its capabilities. Similarly, when I install the Kubevirt custom resource definitions, so I can create a custom resource. Custom resource is a way to create Kubevirt objects. So it will be having same API version. It will be having kind, like kind will be like virtual machine, or kind will be like a virtual machine instance. So it can be there. And apart from this, you can specify it will be having a spec section. So you get the same familiarity with pods or deployments that you have been creating for the virtual machines. So now no more, no more separate segregation over there as well. So that is also another very cool benefit. And containers and VM are running side by side. How cool can it be? How more cool can it be? So use cases, again, mixed workloads, very important use case. Kubernetes on Kubernetes. So that has emerged out a very good use case. Like people can run Kubernetes on top of Kubernetes, and we are doing that at CO. So we leverage Kubevirt underneath our supercluster platform, and we provide a managed K3s service on top of that. So I think we are doing it as a service provider. So you can think that how much good it is for production. Another very good example is of Harvester. So Harvester is there. Harvester is a very good open source tool in the space of HCI, hyperconverged infrastructure, and it also leverages Kubevirt behind the scenes, and it gives you a fancy UI where you can create all your virtual machines, but behind the scene it is talking to the Kubevirt API and doing all that stuff. Building pipelines. For example, you let's say you have a Tecton or some other projects that you can tasks and categorize. So you can actually run a Windows virtual machine and inject some code, have it as a task, and mount your persistent volume claim to it, do that task something, and it generates the artifact for a Windows application and uploads it to a cloud or uploads it to another PV. So I think that is also very interesting use case. And all the other traditional VM use cases are also there, like the virtual VDIs, virtual desktop, the render farms, and all the traditional on-prem IaaS. So all these traditional VM use cases can also be leveraged with respect to Kubevirt and Kubernetes. Let's move on. The basic architecture looks very simple, very neat. You have Kubernetes, plus you have Kubevirt deployed on top of Kubernetes. You have your application pod, application container. So your Kubevirt pod is nothing but a KVM and a QEMU process. So they will be running as a part of the pod. So you will be having a QEMU container which will be running, and it is CRI independent. So it works with CRI-O, it works with containerd, it works with Docker. So now Kubevirt is kind of made in such a way to leverage most of the capabilities of Kubernetes itself, like the storage. So you have the pod can leverage the PVCs. Similarly, Kubevirt can leverage the PVCs, and they are attached at disks. So in a virtual machine, you have disks. So the disks in Kubevirt can be the PVCs. So there's no reinvention of the wheel over here. So you are using kind of the same resources that you are using for your pods, for your Kubevirt as well, for your virtual machines as well. Similarly for network. So the traffic that routes to Kubevirt virtual machine is kind of in the same way that it does to the any other containerized workload. And though there are other network interfaces like Multus is there for additional glowing and interfaces, but but the overall standard networking is interesting, and is kept to kind of use the existing one and not having the custom code over there. So we are using the same, I mean, Kubert is using the same sort of, trying to use the same sort of networking strategy with respect to the containerized workloads in a standard way, not in a custom way with respect to that can only work with Kubert, nothing like that. Now let's talk about the VM launch flow. I think it is very important how the VM launch flow works. That will give you understanding in Kubevirt how it works. So when you are talking about the VM launch flow, you do a kubectl apply VMI. Now there are few CRDs, which is virtual machine instance. Virtual machine instance is actually the pod which gets created, but usually we provide virtual machine. So virtual machine is the upper layer of that helps in the management of the virtual machine instance, like start, stop, and all that stuff. So virtual machine instance, whenever it is applied, the API server picks it up just as regular, do a kubectl apply. API server will pick it up, persist in your etcd, and then you have Virt controller and Virt API. So they are the cluster level components. As soon as, now obviously if you know operators, you know how controller works. So they are watching some set of CRDs. So in this case it is watching VMI. As soon as it is saying, okay, a VMI object is there, I have to create a spec that is understood by the API server, and I have to map the resource request limit, whatever is specified. I have to provide a node name. So scheduler will tell this pod can be scheduled on this node. A Virt controller will add that node name to the spec file, and then the kubelet picks it up. So that is a node. So on the right hand side, what you are seeing is a node, is actual node where your pod or your virtual machine pod will be running, or the VMI pod which will be running. So you have your kubelet, and then you on the node side, there is another component. Now there is another component which is called Virt handler. Now when you install Kubevirt, there is a daemon set that runs on all the nodes. So daemon set is a pod which runs on all the nodes. So Virt handler will be running on each and every node. You'll be having a container runtime, because obviously you have to pull the images and all that stuff. So you need a container runtime. It can be CRI-O, container D, Docker, or anything. Now, Virt launcher is something which will be starting the QEMU process, watching it, and the live migration and stuff. Virt handler is something which is responsible for telling Virt launcher how to start the VM. So Virt handler will be telling how to start the VM and how to launch a VM, and then it will be reporting back to the API server. Virt launcher will be launching the QEMU process or shim process, which will be responsible for starting the QEMU process and maintaining that, and all the other capabilities like live migration and etc. That will be done by Virt launcher over there. So that is the complete flow. And after that, the VM is started. It's a VM pod, virtual machine instance is started. So that's how it kind of works. So I hope the VM launch flow is kind of clear. We'll actually see it in action, how it is working. Now it's the demo time. So we have seen, what Kubevirt is, what its architecture looks like, what VM launch flow looks like. And now we'll actually do a VM live migration. So the cluster that I'm using is CO Kubernetes cluster. You can go to co.com and sign up for that. So let's we are just creating a cluster, and I have given it, I think, 3 or 4 nodes cluster, and I have opened kind of the ports, and I have just created the cluster. I already have a cluster running and the kubeconfig file downloaded, but even if it's not, then it will just take 2 minutes to launch this particular cluster. Then a kubeconfig file will appear over here, and I can download that. So right now the cluster which is available is this one, Kubevirt Ado demo that I've already created. So you can see kubectl get nodes. So the 5 node cluster is already ready. Now what we'll do is kubectl get pods -a. I'll tell you, like, the Kubevirt right now doesn't exist. So you can see, like, we don't have any Kubevirt namespace or pod running. Now in this particular demo, what we are going to do is first, obviously we have to install Kubevirt. That's where we told in the, if you remember the architecture diagram, obviously it's very fresh. So you have your Kubernetes cluster. Now on top of Kubernetes cluster, you want to have the Kubevirt installed. So let's have the Kubevirt installed. So this is just getting the latest version. The latest version as of now is 0.46.1, if I'm not wrong, if something didn't release. Yeah, so 0.46.1, and we'll create the operator.yaml file. Now, what this will create, it will create namespace, and it will create the custom resource definition, priority classes, some roles, because the daemon set will be the word handler pod, which I was talking about, will be running as a privileged pod. So there are some additional, additional permissions which are required for that. Then it creates deployment, a deployment vert operator, and I think 2 replicas are there for that. Let's see, kubectl get pods -n Kubevirt. So everything is getting created in the Kubevirt. Yeah, it creates 2 replicas of that as well. So we have our Kubevirt operator which is running. So now our cluster level component is there. Now let's create the Kubevirt custom resource. So we'll do that, and it will apply the Kubevirt CR, and the Kubevirt, this is created. So kubectl get pods. So you can see we are having a few other pods which is getting created. Now what we want to do is first, we obviously want to create a virtual machine. We will be creating a virtual machine, and it will be doing the same launch flow that I was talking about. So, but before that, we just need a feature gate for live migration, because the demo is for live migration. So we'll create the config map for that. And now let's create the virtual machine. So this is the virtual machine. So in the meanwhile, it is creating kubectl get pods, not this one, get pods -n cube. What? Sorry. So you can see we have word handler pods. So obviously there'll be 5 word handler pods which have started because we have 5 nodes. So I told you, like, daemon set is something which is running on all the nodes. So there are 5 nodes in the cluster. So there will be 5 word handler pods. Controller and the operator is already there. So you'll be having the controller pods, the operator pods. So everything is starting up. So this is the virtual machine that we are supplying. So you can see I was telling the same configuration. So you have API version, Kubevirt, you have kind virtual machine, you have given name, and you have given the spec section. Now in the spec section, we have different stuff, which is the disks. Now disks come from the volumes. So these volumes can be persistent volume claims as well. So you can have your volumes in terms of PVCs, and then you can attach them those as the disks. And then you have interfaces. This is the standard, the default interface, I think, NAT. And then you have resource and request. So you can define here the resource and the request with respect to how much GB or how much memory you want to assign to this particular virtual machines, and it will translate in that particular terms when it gives gives this object to virtual what you call the QAPI server or the Vert API. And after this, I have done Vert CTL. So basically, Vert Control or Vert CTL is a tool to interact with the virtual machines. And in order to download that, obviously, you have to, either you can go in the releases page and download for with respect to the operating system that you're running. I already have Vert CTL. So what we'll do is, as of now, we have kubectl get pods. You can see in the default namespace, we don't have anything. So what we'll do is, and also let me do kubectl get virtual machine, because we created a virtual machine object. We can get that. It is stopped as of now. Now what we'll try to do is we'll try to start this virtual machine. So let's do a Vert CTL start test VM. Now it is starting. It is scheduled to start. We can watch its status as well. We can watch kubectl get VMI watch, and it will tell you, okay, your VMI is running, and it is getting IP, and it has been assigned a node name. So you can see, everything is there. So if I go now and do kubectl get pods in the default namespace, there will be a pod created. It has 2 containers. One should be the QEMU process, QEMU as well. So let's do a kubectl describe pod. So you can see there are 2 containers over there. One will be your is Vert launcher. So I told you Vert launcher will be there, and Vert handler is already there. Now Vert launcher will be launching the QEMU process within the container and all that. And this is the second image. So this is the image that will be using CIROS container, which is for the demo purpose. So that is where it is running. Now this demo is for migration. kubectl get pods. You can see the node name which is assigned is 421A. So what we can do is we'll trigger migrate command, and what it will be doing is it will be actually generating a virtual machine instance migration object. So it will be generating a virtual machine instance migration object and then giving that to the Kube API server. So let's do this and we'll see some of its components till it gets migrated. And I'll show you like the node has been changed. Obviously it will be, so virtual machine instance migration object is created, and here somewhere we define which virtual machine we want to migrate. Yeah, so you can see spec VMI name. So we specify which VMI name we want to migrate. So this is very useful when you are having, eviction or when the nodes go down. So your virtual machine is always running. So that is how it will be doing. So right now the VM is very light. The migration will be very simple. Migration will be very easy and fast. For example, kubectl get pods. If I do, so it will be kind of fast. Yeah, it's already completed, and 46 seconds ago it is already started. Now if I do kubectl get pods -o wide, you can see that the node has changed. So it was 421A. Now it is running on our virtual machine is running on a separate node. So there were 5 nodes. Now our virtual machine is running from node A to node B. So let's do kubectl get nodes -wide and kubectl get svc. So this should be running, and yeah, so migration test. So that's where it is running, and so that's how you can live migrate. So you have seen live migrate. It might take more time, as you might have some PVCs attached or some other other processes which are there, other stuff that you are running inside the VM. So depending on that, it might take some additional time. So it might not be as quick as you have seen now that it migrated immediately from one node to another. Usually it's super quick, but I'm just giving a caution over here, like it can take a couple of seconds more. So that's how Kubevirt is. You have a VDI, you have your you can attach the same set of you can use the same set of power that you're using for your pods with respect to the the Kubevirt virtual machines. I think it's kind of a game changer, I would call, because it is being leveraged in other open source projects. You can see, like, right, the harvester is there. Harvester is itself an open source solution for HCI, hyperconverged infrastructure, where you can install that on a bare metal instances and spin up your virtual machines. And it also powers Kubernetes on top of Kubernetes, but it under the hood it is leveraging Kubevirt. So you can see not only the projects, we at Civo, we are using Kubevirt. We have a super cluster which is using Kubevirt. We are providing managed managed Kubernetes service based on that. So I think there are a lot of awesome use cases that Kubevirt is being leveraged at because of its awesomeness. There are no custom things that are very limited, that I don't know, might be but that are limited only to Kubevirt. But what I have seen, like the storage, the network, all these are interfaced in such a way that it can leverage all the power of Kubernetes, the monitoring solution, be it the storage, be it the networking, all that stuff, be it the independency with respect to the container runtime. So you can have, like, obviously the K3s runs with container D. I didn't configure anything with respect to container D. It is running flawlessly. It is running absolutely. I just installed Kubevirt in front of you. So it is just installing as it is, just running as it is, and independent of the container over there. It is using QEMU behind the scenes. You now know the different components. You have Vert controller, Vert API, Vert handler, Vert launcher. So all these are a very limited set of components that are making the whole story go around of VM and containerized workloads running side by side on a Kubernetes cluster. So I think that's pretty much it that I had from my point of view with respect to KubeVirt. More information you can find on kubevirt.io. You can see the end users, the vendors, the integration that it has with overt. Yeah, it is using libvirt as well. You can try different scenarios. There are different labs. The docs are pretty cool, and obviously you can join the community. You can see the docs which are there with respect to all the stuff that you can do, authorization. Yeah, also you can leverage the Kubernetes authorization for the VM. So I think that's pretty cool stuff that you can do. You can use, I think GPU work is going very strategically. There was a talk on GPU at KubeCon as well. So GPUs, with how to use GPUs with respect to KubeVirt virtual machines. I think they are very good. Yeah, they integrate very well with the service meshes. So Istio service mesh, you can see over here, they integrate very well with Istio service mesh. Disks, volume, PVCs, storage vendors, they are integrating very well with respect to the CSIs. All CSI they will be running. Okay, so let's wrap up this session. Thank you so much for staying till the end.